everybody, so this is Mrs. K's way of combining like terms. We've talked about this a little bit in class, but here's our official video, so make sure that you take some notes. Our first example is very elementary, 5 plus 7. So I'm taking two different constants, 5 and 7, and I'm adding them together. Of course, visually we can see that this means that I have 5 of something. And then I'm adding 7 more. So 1, 2, 3, 4, 5, 6, 7. I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my final answer for 5 plus 7 is equal to 12 wholes. So my 12 constants. When we're talking about it with variables, all we're saying now is that if there is 5 x's and then there's 7 more x's, if I just write that out as 1, 2, 3, 4, 5 x's, and I have 7 more, then in the end I'm adding my coefficients right here of 5 x's plus an additional 7 x's to give me a total of 12 x's. So all I really did is just add the 7 and the 5 to give me 12. Pretty basic. Well, let's talk about this idea of the hidden one. When I see that I have a variable m, I see that how many do I have? Well, I only have one m, but I never actually say 1m, I just usually say m. But when we're talking about our coefficient here, I have a single m, so I can always put a 1 in front of it. And for an example, if I had 3m plus m, I know that I have 3 m's plus another 1m, so I have a total of 4 m's for that problem, because I'm still just adding those coefficients and having 4 of my variable m. Over on this side, can we have 0? Well, if I follow my different rules of adding and subtracting the coefficients, let's see what happens. If I have 2z plus 3z minus 5z, I know by my order of operations I must start on the left to go right. So 2z plus 3z gives me 5z. And if I pull down my subtraction of another 5z, I know that 5 minus 5 will give me 0z. Since 0 times z is the same as multiplying anything by 0, I have a final answer of 0. So yes, can we have 0? We can. As long as the two coefficients, like right here was 5 and 5, if they cancel, then they of course are also have a final answer of 0. So now let's look at an example with more than one variable and a constant. If I want to combine my like terms, the first thing I need to do is I want to circle and square my like terms. So I see I have 2 x's, I have 2 y's, and then I also have a constant. I like to be able to mention these with circles and squares and triangles so that I know what's really going on. I can also do it by adding different colors, but since for the most point I'm using my pencil and paper and not always my iPad, I want to be able to distinguish them separately. So the first thing I want to do is my x's. So 6x minus a 3x is going to give me, so 6x minus 3x gives me 3x. And now for my y's, my 4y and my y, so 4y plus y. I remember that little hidden one, so I want to add him right there to give me a total of 5y. And then I also see that I have my constant of 7. I don't need to add or subtract anything with him. So my final answer is I'm going to add all these together, and my final answer is 3x plus 5y plus 7. I cannot combine my x's and my y's because I do not have the same variable. So x's and y's do not combine. And I can also not combine my constants with my other coefficients, because those coefficients are being multiplied before they're added, so I need to follow order of operations. Thanks so much, you guys. Here's poor Callie. Since she had surgery on Friday, she has the cone of shame. So please send her some well wishes to get better, and hopefully you can see her when she is up and running again. Thanks so much, guys. Bye.